Last class, we talked about the continuous and discrete distributions. This week, we're going to talk about expected values. What do you guys know about expected values?
Expected value, the integral or the sum from negative to positive infinity of x times f of x, the distribution's probabilities. In fact, it's something you've seen. Expected value is also the mean.
Sure. However, unfortunately, the expected value doesn't always exist. In order for the expected value to exist, the integrand or summand must also converge absolutely.
That is to say, in the discrete way, for some x f of x to infinity, the absolute x f of x must converge, otherwise e of x doesn't exist. I didn't want to tell you, but I couldn't resist.
Correct. For example, let x be a random variable that takes values 1, -2, 3, -4, and so on, which has respective probabilities c over 1 squared, c over 2 squared, c over 3 squared, and so on. Note that c is a number such that the probabilities sum up to 1. If we didn't have this rule, then we would expect the sum of x times f of x to be ln 2. However, since the summation of the absolute value of x times f of x doesn't converge, then the expected value doesn't actually exist. There are also certain properties that the expectation function follows. Any ideas?
Expected value of a is equal to a. Its mean is itself. It's always that way. Times x by a c, well, that is what's next. E of cx is c, e of x.
That's right. The linearity property also allows us to bring the expectation inside the summation. Let y be a random variable such that y is the summation of xi's. To find the expectation of y, we only need to know the expected value of the xi's and then sum them up.
It's awesome. It's cool. It gives me the sensation to know the expectation of the sum is the sum of expectations and linear combinations. Exactly the same concept applies. Expectation of this is a e of x plus b e of y.
Come on, man. Is that all we learned in Waterloo?
Well, we learn about the variance, but that's an expectation too. There are two formulas that we commonly use. They're equivalent, and this can be proved. Prove it.
Now let's see how these can be applied to some common distributions.
For Poisson, the mean and variance are the same, but that's not the only distribution in the game. Uniforms is a plus b times a half. To rob the mean eating noodles at DC Cap. And the mean of binomial is MP. That's right. Put that on your cheat sheet. How about the variance? And 1 minus p,